Welcome to aminacademy.com. In material science and engineering, let us discuss about briefly an overview of atomic structure. All the materials available either in solid, liquid or gaseous form are made up of atoms, the smallest invisible particles. Atoms of the same element are identical to each other in weight, size, and all properties, whereas atoms of different elements differ in weight, size, and other characteristics. The size of the atoms is of the order of 1 angstrom unit. That means 10 power minus 10 meter. Here, size of an atom 1 angstrom unit, that is 10 power minus 10 meter. A material which consists just one type of atom is called element. For example, nitrogen, carbon, hydrogen, aluminium, copper, gold, iron, etc. are a few examples of elements. Group of atoms which tends to exist together in a stable form are called molecules. For example, hydrogen molecule, oxygen, nitrogen molecules. Large number of molecules in nature exist as combination of atoms of different elements. For example, water, that is H2O, carbon dioxide, CO2 like. Molecules containing one atom known as monoatomic, two atoms known as diatomic, three atoms known as triatomic, and more atoms known as polyatomic. Atom is considered to be made up of heavy nucleus consists of protons and neutrons surrounded by a highly structured configuration of electrons revolving around the nucleus in shells or orbits at a relatively greater distance from nucleus. The size of atomic nucleus size of an atomic nucleus is approximately 10 to the power of minus 14 meter, whereas the density is very heavy, that is 10 power 2 into 10 power 17 kg per meter cube. Now, in shortly, atoms consist of an extremely small positively charged nucleus surrounded by a cloud of negatively charged electrons. Although typically the nucleus is less than 1/10,000th, that is 1,000th of the size of an atom. That means most of the area is empty. The nucleus contains more than 99.9% of the mass of the atom. Now, let us discuss about an electron. An electron is negatively charged subatomic particles that can be either bound to an atom or free, not bound. These are electrons. Then electron that is bound to an atom is one of the three primary types of particles within the atoms. The other two are protons and neutrons. Together, protons and electrons form a atom's nucleus. That is, atomic nucleus contains proton and neutron. In 1897, J.J. Thomson, while studying a passage of electricity through gases at low pressure, observed that rays of light appear to travel in straight lines from the surface of the cathode and move away from in the discharge tube. These rays are called cathode rays since they start from the cathode of the discharge tube. That is, J.J. Thomson. J.J. Thomson found neutron. Neutron travel in straight line and cast shadows carried negative charge and sufficient momentum, possess high kinetic energy, and can induce some chemical reactions, excite fluorescence on certain substances. Here, mass of one charge, mass of electron is mass of the electron is 1.602 in 10 power minus 19 coulomb charge of one electron, and specific charge E over m, the ratio between the electronic charge and the mass of the electron, found its value as E over m, E by m ratio is called charge per mass equal minus 1.76 into 10 power 11 coulombs per kg. The electron obtained from different sources throughout the world are found the same and have identical effects when used for any applications. The electrons emitted in the cathode rays have been found to exhibit identical features in different modes of cathode ray discharge tube. The rest mass of an electron m0 equal 9.9109 into 10 to the power of minus 31 kg. Now therefore mass of an electron while moving equal m0 over the square root of 1 minus v squared over c squared, where v equal to velocity of the electron moving, c equal to velocity of the light. Now de Broglie wavelength. De Broglie wavelength equal, that is lambda equal h over mb, where h equal to Planck's constant, m is mass, and v is velocity of the electron, where h value equal Planck's constant is 6.626 into 10 to the power of minus 34 joules second. Next we'll discuss about a proton. Proton, one of the three basic subatomic particles, along with neutrons and electrons that make up atoms. The basic building block of all matter and chemistry is these are the three things. It is the positive charged particles that, together with the electrically neutral particles called neutrons, make up the nucleus of an atom. The nucleus of the ordinary hydrogen atom is an exemption because it has no neutron. It contains only proton but no neutron. Here, the magnet, that electron same charge, neutron have no charge. Now next one is, that is proton have charge is positive charge, that is 1.602 into 10 power minus 19 coulomb. The mass of the proton is equal 1.672 into 10 power minus 27 kg. Here, next, the mass of proton is 1.672 into 10 power minus 27 kg. The proton and the neutron are considered to be different charge state of the same particle, which is called the nucleon. The number of protons in a nucleus is called the charge Z of the given nucleus, or the charge number. Charge number is equal to number of protons. Neutron, you can see charge number or atomic number equal Z, which is equal number of proton or number of electron. Next is neutron. Neutron, along with protons, are subatomic particles found inside the nucleus of every atom. The only exception is hydrogen. Hydrogen, where the nucleus contains only a single proton. Neutrons have a neutral electric charge, that is neither negative nor positive. There is no charge for neutrons, and have slightly more mass than positively charged protons. Therefore, particles have 1.008 times heavier than proton. Neutron, 1.8 times heavier than proton. The mass of each neutron is 1.675 into 10 power minus 27 kg. Each neutron is composed of one proton and one electron. Therefore, you can say each neutron composed of one proton plus one electron. Next, atomic number. The atomic number of an element is determined by the number of protons in it, and it is used to differentiate one element from another. The mass number of an element is determined by the number of protons and neutrons combined. That is, atomic number Z equal atomic number is number of proton plus number of neutron. No, atomic number is only therefore atomic number of mass, this is a mass number. Mass equal proton plus neutron. Atomic mass equal to number of proton, that is atomic weight. Here mass number is number of proton or number of the atomic number of an element is determined by the number of protons in it, and it is used to differentiate one element from another. The mass number of an element is determined by the number of protons and neutrons combined. Mass is proton and neutron. That is next is atomic weight or mass number. The mass number is the sum of the number of protons and neutrons in an atom. It is a whole number. The atomic mass is the average number of protons and neutrons for all neutral isotopes of an element. It is identical number. Look at here. Suppose oxygen have atomic number is 8, that is Z is 8. Element symbol is O. Atomic mass is nearly 15.999. It's approximately, we are using 16. Now, atomic number A equal number of protons and number of neutrons. Here, mass number is the atomic number and mass number, little difference here. For example, an atom has 17 protons and 18 neutrons in its nucleus. Obviously, mass number of chlorine is, suppose chlorine have 17 proton and 18 neutron. So 18 plus 35 here comes. This is a chlorine atom. The mass of an atom, mass of an atom usually expressed in terms of atomic mass unit. Unit AMU. That is 1 AMU is approximately equal 1.6603 into 10 to the power minus 24 gram. Hydrogen has 1 mass unit and carbon has 12 mass unit. 1 mass unit is equivalent to 1.6603 into 10 power 24 gram, minus 24 gram. Next, isotopes. Isotopes are member of a family of an element that all have the same number of protons but different number of neutrons. The number of proton in a nucleus determines the element's atomic number on periodic table. For example, carbon has 6 protons and its atomic number is 6. But carbon have different isotopes. Here look at, for example, hydrogen 1, mass number is 1, hydrogen 2, deuterium, mass number is 2, means 1 neutron is in the nucleus. In hydrogen 1, mass number is 1, that means no neutron, only 1 proton. Look at here, hydrogen 3, tritium, it's called, mass number is 3, means 1 proton, 2 neutron. So the nucleus contains 2 neutrons. So its mass number is 3. That means having same atomic number but different mass number of same element is called its isotopes. Here in isotopes, for example, carbon have 2 isotopes, chlorine 17, chlorine 35 and 17 chlorine 37. Therefore, the average atomic weight is 37 into 3, abundance is 3, that is 3 times, and 35 into abundance is 1, divided by 4, which gives 35.48. That means due to two isotopes of chlorine having average atomic mass unit, weight is equal to 35.48. Next is isobars. Isobars are atoms, that is nuclides of different chemical element which differs in the chemical property but has the same physical property. Means different chemical properties and differs with the chemical property but has the same physical property. So we can see that the isobars are those elements which have a different atomic number but the same mass number. Here sulfur and chlorine and argon have different atomic number but same mass number. Look at here. Here sulfur have atomic mass number is 40, chlorine has 40, and another sulfur is 40. That means here 3 sulfur, chlorine and argon are examples of isobars. Next is isotones. Isotone, any of 2 or more species of atoms or nuclei that have a same number of neutrons. Thus chlorine have 37, for example, and potassium have 39 are isotones, because the nucleus of this species of chlorine consists of 17 protons and 20 neutrons, whereas the number of this species of potassium contains 19 protons and 20 neutrons. So these are isotones. Look at oxygen also. For example, oxygen is 8O16, nitrogen have 7, oxygen has 8O16 and nitrogen have 7 and 15. Here also look at here, neutron is same everywhere. That is oxygen, nitrogen, carbon have same neutrons. It's called isotones. Avogadro number. Avogadro number, the number of units in 1 mole of any substance defined as its molecular weight in gram, equal to 6.02214076 into 10 raised to 24. The units may be electrons, atoms, ions or nucleus, depending on the number of nature of substance or the character of the reaction. Here, for Avogadro number is very important number in chemical calculations. Atomic nucleus. The nucleus of an atom is the central region of an atom where the majority of the mass is concentrated at nucleus. Through the scattering of alpha particles experiment by Rutherford, we learned that the nucleus of an atom contains a majority of the mass of the atom. Numerically speaking, the nucleus of an atom occupies almost 10 power minus 14 times the volume of an atom but contains 99.99% of the atomic mass. Atomic mass is very, compared to electron, it's very heavy and size is very small. The nucleus of an atom is so small that if you expanded an atom to fill up a room, the nucleus of an atom would still be larger than the pinhead. That means consider one room is an atom, that pinhead is a nucleus. So far we discussed briefly about an atomic number, atomic mass, isotopes, isobar, isotones, and that masses of electron, neutron, proton, like that. If you had, please subscribe our YouTube channel.